Guys, that is just a calculator question right there. All right, and I'm telling you, you could use your calculator or your device. 2 minus 0, just 2. Hopefully you don't need a calculator for that. And then -3 minus 5, it ain't 2, it ain't -2. Like, didn't we say we're going to get an answer that's like kind of a small number, right?
Yeah.
Okay, so -3 minus 5, what would that give you? You owe $3, you owe $5. What?
-8.
Now, we have 2 over -8. We have a positive divided by a negative, so we know our answer is going to be negative.
No.
No.
Okay, let me tell you, let's just stop. Put your pencils down, look up here. It makes me want to throw up. All right, guys, oh my goodness. What's wrong with this? What's wrong? Yeah.
It's too large of a number.
Okay, yeah, why? How come 2 divided by -8 is not -4? I thought a positive divided by negative is a negative. But it's not? Positive divided by negative is not
But
negative?
you have to have the 1 on top.
Okay, yeah, more or less, yeah. Jonathan, what do you have to add?
That is 2 over 8, not over 2.
Thank you. Guys, A over B is not the same thing as B over A. You cannot just flip-flop those things around. Guys, 8 divided by 2 will give you 4, or negative, -8 divided by 2 will give you -4. But this says 2 over 8, or 2 over -8. It's not the same thing. You bet you that's going to be one of the answers if it's a multiple choice test. It's not -4. Didn't we say the bigger the number, the steeper the slope? -4 would be something like this. This is going to be a small number. It's going to be a number less than 1. So, knowing that, what do we do with this? Okay, what do you mean, divide it? Like this says 2 divided by 8, or how many times will 8 go into 2? Well, it can't, so you're going to get a decimal. You don't ever write this as a decimal, you want to leave it as a fraction. Which number will go into both 2 and 8?
2.
Yeah, how many times will 2 go into 2?
1.
How many times will 2 go into 8?
4.
Instead of -4, your answer is -1 over 4.
Is it okay if I got point from the bottom?
Technically, you're not wrong, Jonathan. But where we're going from here, you're going to want to leave it as a fraction. Okay, did y'all hear that? Leave it as a fraction. Don't change it into a decimal. All right, even if the fraction is like 9 over 2, leave it as 9 over 2. Don't change it. All right? Do y'all have any questions about the first one? All right. No questions on this. Amazing. All right. Question number 2. We're going to find the rate of change from that table. Miss Porter, which 2 ordered pairs do we pick from the table?
I picked the first 2.
Do you always pick the first 2?
No. Yes.
Will you read out the x values for me, Miss Porter?
0, 6, -3, 12,
12. And then what are my y values?
4, 8, 2, 12.
All right. So there. That's what the table looks like. I said, which 2 ordered pairs do we use? And she said the first 2. Guys, you don't have to use the first 2. There's kind of a trick question. You can use any point that you want to. You can use the first point, the last point. You can use the second point, the third point. It doesn't matter. Because all these points are seemingly random up here anyways. The x's are not going from least to greatest. They're just a bunch of points that make a straight line. So it doesn't matter the points that you pick. We're talking about the steepness of the line that goes between them, and the steepness is going to be the same. So which ones did you pick?
The first 2. 0,
All right.
6, 4, 8.
And we're going to do this right here, yeah?
Yeah.
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 This is, okay. This is very helpful when we're dealing with negative numbers, but let's do it like this, and I want to show you kind of another way of looking at it. Ms. Porter, since you want to use the first 2 ordered pairs here, what are your y values?
8 and 4.
Yeah. Are we going to put a 0 and a 6 up here in the top?
No, sir.
No. 4 and 8. Would you rather do 4 minus 8 or 8 minus 4?
-4.
8 minus 4 is going to go here. So there's your 8, and there's your 4. And then what numbers go in the, what do you put in the bottom? Tell me the order matters.
6 and minus 0.
6 and 0 go in the bottom. 6 and 0. And then 8 minus 4 will give you 4. 6 minus 0 gives you 6. And oh my goodness. Guys, if you left it like that, technically it's not wrong. Technically it's the rise over the run. You rise 4, run 6. That would be the rate of change. That would be the slope. It's not going to be your answer on a multiple choice test. If this is what you got, and you look at A, B, C, and D, and they don't say 4, 6, you got to know which one simplifies down to 4, 6, or what 4, 6 simplifies down to. Yeah.
Could they ever possibly have like 4, 6 and then a simplified version of it?
What do you mean?
Like on the multiple choice, could it say like 4, 6, but then it also say the.
No. No. I mean, it could say which of the following does not represent the slope, and it'd say 4, 6. It would have different representations of 2/3, which is what this is. I mean, you'd have 2/3 and 4, 6, and then 6 ninths, and then and then you have like 1/10. And you have to pick 1/10 is not the rate of change. All the other ones are. Guys, look. Hey, Rod, you paying attention?
Yes, sir.
Look up here. Hey, Rod, what's the change between 4 and 8? When I say change, what operation am I talking about? How does it change going from 4 to 8? Are we going up or down? By how much? Hey, Rod, how much are we changing in our x's? Are you going up or down? From 0 to 6? No. To go from 0 to 6, are we going up or down? Is it increasing by 6 or decreasing by 6? It's decreasing would be 0 to -6. We're increasing. We're going from 0 to 6. So the change in y is 4 and the change in x is 6, which is what we got right here. So this right here, this is what we use for negative numbers. I want you to use this method, but if you don't have negative numbers, I think it's a shortcut to just do it like that. Simplify it that way. You have any questions about number 2? It's amazing. Everybody knows the answers already, huh?
Yep.
Great. All right. This is what I want you to do on question number 3. I understand, guys. Look, it's hard to duplicate, or it's hard to get on your paper what I have on my board. I mean, it's just difficult because this is not what I'm looking for. Well, let me draw this first. Okay. What?
I used a stamp for the first one.
You did what now? For the first one?
Yeah.
Oh my gosh.
I didn't even get a stamp.
Who was my stamp person?
Why didn't you give me a
Should've
stamp?
talked
Gosh, so
so you
rude.
Remember, told me that you didn't get a stamp.
Yeah, Frankie.
Yeah, Frank.
Don't call Frank.
Frankie.
Oh, that's so much.
What was that?
Oh, no.
Filthy
He
rich
said-
Frankie.
Yeah, that's what he said.
Yeah, that's totally what
Yeah, that's
Yeah,
totally
that's
what you
totally
said, Neil.
All right, guys, make yours look like mine. Now, what I'm not looking for is I'm not looking for you to go like this. All right,
That's pretty
now what I'm looking for, make yours look like mine.
You're gonna have to edit this.
No.
Oh.
I'm making it a point this year to really stop and focus on this because this is generally where kids struggle with rate of change. You know, equations, you just look at the number in front of the x. It's not rocket science. With tables, most kids can look at the pattern at the top, look at the pattern at the bottom, do the change in y or the change in x. As long as you follow the steps that I've showed you that are in your notes, you'll do just fine. Same thing with how to do the rate of change between two ordered pairs. From a graph, this is where kids really start to struggle. What's the best way of getting that graph onto your paper? What do you think, man?
Looking at points where the y and x intersect.
Jonathan is saying what I would do is I would look at points that are on that line. Like what would be an ordered pair from that line right there. And then I'd plot the points, and on my paper I put the line through the points. All right, that's exactly right. Before we get there, I mean, yes, I want you to do that, but we're going to do that here in just a second anyways. What is the guys, listen to me. You will get this question wrong if you don't follow this step. I'm telling you how to do this thing. My first period class, not one of them did this. What do you do first here?
Make a graph.
No, after we do that, here's our steps right here.
Write down the points.
You do the sign first. Guys, if you get an answer for this question, it's not going to tell you whether it's positive or negative. You've got to determine the sign first on your own. Is this line increasing or decreasing?
Increasing.
So we're going to come right here, and this is where we're going to put our answer. We're going to put a little plus sign. That's what I'm looking for on all y'all's paper. Now, if the slope is 6, you wouldn't write it's plus 6. You just write 6 because it's an understood positive sign. But that's what I'm looking for you to tell me, hey, I did figure out what the sign was first. A lot of kids getting these wrong because they're not following step 1. And it's like y'all know how to do all this great math, but you're not listening to what I'm telling you. Now, the second thing says, if we do not have points on our graph, you got to get them. And this is what Jonathan was talking about. I would not put one of my points right here. Is that a point on the line?
No.
Sure. Yeah. But it's not going through an X and a Y. It's not like an ordered pair that would give you like 1, 2. This ordered pair would be like 0.75 and then 1, 2, 3, like 3.5. Like, you don't want to use those as ordered pairs. You could, it would make your life very hard. You want to pick where this line, hold on. Oop. You want to pick where this line is crossing both an X and a Y at the same time. Let me say that again. You want to look at where this line is crossing an X and a Y at the same time. So if I just follow this line right here, what? Nope, not crossing a Y. Hey, right there, I have a point. Okay? And if I just kept following this line, there's a point right there as well. And then there's one right there. And then there's one right there. You see how all of these points are crossing an X and a Y? Y'all see that? You don't see that? Like, A-Rod, don't feel, look, this is where kids struggle. They don't see this. When we're plotting an ordered pair, you're saying like 1, 2. You say 1, 2. That's where your point is. You see how it's crossing at an X and a Y? That would give you a whole number for your X value and a whole number for your Y value. You want to get whole numbers for your X's and your Y's. So, here, this green line, our graph, is crossing here at X and a Y. Okay? You see that? You see how this point right here is crossing an X and a Y at the same time? Whereas like this point right here is not crossing an X and a Y. You're looking for where the point is intersecting to make a whole number, okay? If you don't get it, A-Rod, you will, and I'll work on it with you today, all right? Like some kids just don't see it right away for whatever reason. I get it. All right, so now what? We got points on our graph. What you think, Sophie? What do we do now? Why don't you read the step to us? We just did step 2.
Move from one point to the next by rise or run.
We're going to go from one point to the next by using rise over run. Now, what we're going to do is we are going to go up or down, and you always want to go to the right. So, y'all just take note of this. If I'm going to use this ordered pair and this ordered pair, start with the ordered pair that's on your left. Start with the ordered pair that's on your left. No matter if it's going up or if it's going down, start with the ordered pair that's on the left. Because that, you're going to be going to the right. And you always want to go to the right. So if I'm going to go from this point to this point,
Move over 1.
so go over 1,
And go up 3.
so it's 1 over 3.
No.
All right?
No.
Why is that wrong?
But you didn't go.
Why is that wrong?
Let's go up.
Rise.
Say it again.
Let's go up first.
Yeah, you got to go up first, okay? You got to go rise over run. So, look, the red line is going to be the correct one. You're going to go rise and then to the right. That would give you 3 over 1. So your final answer here is positive 3. All right? And then you want to ask yourself, does this make sense? Does that line look like it has a steepness of 3? All right? It's just kind of like 1, 2, 3. If you got an answer of 1/3, guys, 1/3 would look like this. It would be a very flat line. All right? So when you're done, ask yourself, does this make sense? Now, look at the, running out of colors here, the turquoise line here. If I started at this point here, and I wanted to go to this point here, would I get the same thing?
Yes.
Why, Colin?
Because you'll still get 3. The fraction will be bigger, but you'll still get 3 when you
Well
simplify
done.
it.
Very, very well done. He said the fraction will be different, but when you simplify the fraction, it'll give you 3. Because we're talking about the steepness of the line. We're not talking about the distance between the points. We're talking, guys, the steepness from here to here is the exact same as it is from here to here, because you're going at a constant rate. So you go up 1, 2, 3, 4. Well, I'm counting wrong. 1, 2, 3, 4, 5, 6, and then you go over 2. So your rise is 6, your run is 2. What's 6 divided by 2?
3.
Yes. So it doesn't matter which two order pairs you pick. Are y'all with me on that one?
Yes.
Okay. You can put it that way.
Oh,